What is it? All right. Boom. My favorite articles. Hello, everyone. Hello, hello. Yes. All right. That's good. Hello, hello. Hey, hello, Jacko. Hello, 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 hello. Yes. It's Thursday. Let me just say before I begin, this is one of my favorite things to do during the week on Thursdays. It's fun. It's engaging. Always a lot. Hey, CG underscore Happy Mac. Hello to have you back again. All right, we got a minute. Okay. Hello. All right, so mic check. Hello, Nick Rice Bullhole, Max. Hello, 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 everyone. Hello, hello. I feel like I finally, after how long I've been doing this for a year now, I finally feel like I got the setup all good. All right, it's that time of the day, that time of the week again. Mic check, audio check, video check. How does everything look? Check, check. How does everything look? Okay. Hey, that guy. How are you? Okay, so everything looks good for now. Okay, to stop at the it's 4:30 p.m. Eastern Time. Hello, everyone. Welcome to another Thursday on Twitch for the Introduction to Security class at Tufts University. I'm Ming Chow, Associate Teaching Professor. I have that spiel. So, again, this is one of those Thursdays are days I look forward to because it's almost the end of the week. But let me just say, I really, really enjoy Twitch a lot. It's it's an engaging platform. Um, it really democratizes the education, and I'll say this again. Um, it makes teaching a lot. It feels like a lot less thankless of a job. It's a lot of fun. Um, Maybe one of these days I'll actually fire a game of FIFA and play on Twitch. So today is there will be something new for on this Twitch session today because I actually will be showing a video of a special guest, um, John Hammond, a cybersecurity professional, very well known in the cybersecurity field. But today, the gist of today, we're going to talk about Scapy. Scapy is a module in Python that can allow you to do things like packet manipulation. Yeah. So you can write programs in Python to manipulate network packets, um, and also for good and bad. I'll give you an example just off the top of my head right now. You can use Scapy to write a program to identify plaintext username and passwords. You can use Scapy to actually conduct denial of service attacks. You can write a program in Scapy and Python to monitor networks. Yeah, so you can do quite a lot with Scapy. Um, it's a tool that I love. It's a tool that I use all the time. Very well used in the on the field as well. But before I get into Scapy, I call it Scapy. Some people call it Scapy. It doesn't matter. But before we get into the programmatic side of Scapy and Python, let's understand why we will talk about Scapy and Python. And let's take a step back and let's understand a little bit about the problem we're trying to solve. And the problem that we're trying to solve is, and a motivation behind it is this I have on the screen: distributed denial of service attacks. Look, look, if you do a simple search for DDoS attacks and you want to take a look at the news, like go to news, um, distributed denial of service attacks always makes the news. It always makes the news. Someone yesterday asked in the Zoom class for the online master's program, have anyone ever been caught with a distributed denial of service attack? And wound up, there it is from 7 hours ago. Bandwidth hit with DDoS attack, record. Let me click on this article on Tech Digest. Record 5.4 million DDoS attacks reported in the first half of 2021, claims. So what a distributed denial of service attack is. What a distributed denial of service attack is a common attack. It's one that is not gone away, is to flood an internet victim, just a flood a target or a victim with so much traffic. So to render the entire website or the entire architecture inoperable. Give you a really good example. Sadly, one of the most vulnerable networks out there are one using K-12 education, like in elementary school, high school. Look, the thing is, a lot of public schools are already strapped for cash and resources already. They become quote unquote easy targets. It's not like banks will have all the resources in the world. So there, people like to bring down the infrastructure at K-12 school because they're easy targets. Some of you folks, this is a real joke. This is also an example of a distributed denial of service attack. When so many people are still up to this day trying to find an Xbox Series S or X or a PlayStation 5, and they just flood the website or servers with so much traffic they can't use it, that's actually an example of a distributed denial of service attack. But the technical details, like, I think the not so interesting, one of the interesting questions, but it's not the focus of today, is okay, is there a way to defend against distributed denial of service attacks? And I've always said this is one of the hardest problems in cybersecurity, one of the absolute hardest problems in cybersecurity. When I started learning about cybersecurity in 2004, distributed denial of service attack was a thing. Now it's become even more of a thing, and it's gotten a lot worse because of one of the big reasons why distributed denial of service attacks have gotten so much worse is because we have a growing number of architecture and systems like on the cloud, and also so many devices now are hooked up to the internet, in which if they are not updated correctly, or if they get caught with malware, or what they call to get owned, they become used to conduct distributed denial of service attack without the owner actually even knowing about it. The problem has only gotten a lot worse for distributed denial of service attack, and the volume of traffic has just gone up and 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 up. So trying to defend against distributed denial of service attacks is extremely hard. This is like an academic research area, one that also a lot of companies like Cloudflare, for example, they invest a lot of time and energy on. That's a lot of their business. I don't want to, plug any, I don't want to plug sales or anything, but one of the things that they have, um, if you go to cloudflare.com, one of their big business areas is to defend against things like distributed denial of service attacks. What we got here? Yeah, mitigate DDoS attacks. DDoS protection and secures websites, application. Here we go. They're not compromised. Cloudflare 100 terabyte network blocks on average 87 billion threats a day, including yada yada yada. I mean, this is what they do. But one of my favorite articles that I love to use for today's session, and also to understand the bigger thing is how our distributed denial of service attack really conducted these days, is this article right here on DNS amplification. Attacks. This was written in 2012, but it really gives a real good technical overview on how is distributed denial of service attack conducted these days. So back in the ye good old days. So what an amplification attack and what an amplification attack is a way for an attacker to magnify, said right here, the amount of bandwidth that they can target at a potential victim. Imagine if you're an attacker and you control a botnet, which is like compromised computers capable of sending 100 megabytes of traffic, yada yada yada. In order to increase your attack volume, you can try to add more compromised machines to your botnet. Or the alternative way is amplify your 100 megabits per second into something much bigger. So one of my favorite examples, in the good old days, there was something called a Smurf attack. Now the Smurf attack uses ping. Now ping is a very simple protocol. It's also very small. The number of bytes to send ping, like a ping request and a ping echo reply, is tiny. Okay. Now here is the key. The key is the attacker spoofs the source of the ICMP request to be the IP address of the intended victim. Right there. That is the key. Hint, hint. That's an important line. And why is that an important line? Because that will allude to why you want to use tools like Scapy, which is the gist of today. Now, since ICMP or ping does not include a handshake, the destination has no way of verifying if the source IP address is legitimate. The router received the request and passes it all along to all the devices sitting behind it. All these devices then respond back to the ping. The attacker is able to amplify the attack by a multiple of however many devices are behind the router. So in this example here's a victim the victim is at 9.9.9.9. Here are 1, 2, 3, 4, 5 devices, probably compromised. 1.1.1.2, 1.1.1.3, 1.1.1.4, 1.1.1.5, 1.1.1.6. I'm the attacker. I tell each and every one of these devices, I send each and every one of these devices a ping. But I tell each and every one of these devices that the source is from 9.9.9.9. So I actually fudge or spoof the source IP address. Okay? So the victim will receive a whole bunch of ping replies, and it's like, what the hell is going on? I have no idea. Well, Smurfs are a thing of the past. For the most part, routers and systems actually do not even respond to ping requests. However, the idea of the amplification attack vector is still very much alive. You can amplify your distributed denial of service attack by increasing the number of devices and also the size of the response sent by a query. So here, this again, you can follow a pattern here. The pattern is this. There are two criteria for a good amplification attack vector. One is that the query can be set with a spoof source IP address by way of a protocol like ICMP or UDP that does not require a handshake. And two, the response to the query is significantly larger than the query itself. So, one example is domain name systems. Oh man, I always forget what DNS really stands for. Ah, DNS, domain name systems. Okay. Sometimes I say domain name server. It's the yellow pages from IP from domain name to get domain name from domain name to IP address. So the query is like example for DNS is dig. Here's an example of a query and a gigantic response from that command. Boom. All right. That's a 64 byte query that resulted in a 3,223 byte response. In other words, an attacker is able to achieve a 50-time amplification over whichever traffic that they can initiate to an open DNS resolver. They're all over the internet. But I want to come back, and the real pattern is this. Query can be set with a spoof source IP address. Yada yada, here it is. So, you may be wondering, wait, I can actually create a network packet with spoof source IP address? Like, I can actually, create a network packet. You know, the one with all the layers of the OSI model, and I can actually fudge the source IP address to anything that I want? The answer is yes. The answer is yes. So, you can do it on a low level using a programming language like using like C or assembly. You can do that. Or if you hate C, and let's not go there. We'll talk about that later on in this course. If you're a huge fan of Python, there is a library that is very well known and used in the cybersecurity field called Scapy. Scapy. Scapy is scapy.net. And I'm going to paste the website. Scapy.net. Packet crafting for Python 2 and Python 3. Keynote right now, Python 3 is, Python 2 has been deprecated. Use Python 3. So here is what Scapy is. Scapy is a powerful packet manipulation program. You can use Scapy to both read and write packets. You can read PCAP files as well. It is able to forge or decode packets of a wide number of protocols. Send them over or send them on the wire, capture them, matches or requests replied, and much, much, much more. Okay? Thank you so much, that guy. Thank you so much. Okay, I'm not going to go on a bad-mouthing session here on C. We can do that on Twitter if we want, or on Discord, and we'll certainly badmouth C later on this course, but not today. Okay, so thank you so much. Yeah, Python. A lot of things were written in C. Yes, a lot of things were written in C. It can easily handle most classical tasks like scanning. Ooh, I can write a scanner in using Scapy. Trace route and scanning, probing, unit test, attack, or network discovery. Yep, you can do right. You can write programs in Python using Scapy to do all this. Scapy actually works on all operating systems. If you're on Mac OS, now I want to let you know that here I am. So, if you are on, I know a lot of people on this probably on this on this show right now using Mac OS with Python. So it's user bin Python. Don't use that one. What you want to use Python 3. So I am using Python 3, which was installed by way of Homebrew. So if you have Mac OS and you want to work with Python 3 and Scapy natively, not by way of a virtual machine, you just do brew install Python 3. And it's already installed for me, so it just can say, okay, I can go and reinstall it. Once you do that, you do pip3 install Scapy. That's all you got to do. It's already installed for me. Okay? That's it. That's all you need to do in order to start working with Scapy natively on Mac OS. I'm going to use a terminal a little bit later. They have a little shell demo here. So there's a couple of ways. So, maybe I do need to bring this up. So once you actually install Scapy, you have one or two options. One, you can use the interactive terminal. You type Scapy. And here you go. And you can do a whole bunch of things. You can do all your commands by way of a command line here. I don't need this. I'll show something later. Now, the other thing is you can also write programs using Scapy. We'll get to that in a little bit. Okay. How do we install Python 3 on Kali? It should be already installed automatically for you. That's a good thing. So actually, on Kali, why don't I fire that up right now? Hold on. I actually need the virtual machine. Wait, what? Wait, you may be all shocked and everything that I got a virtual machine running on a Mac. I have an M1 Mac, an Apple Silicon Mac, but wait a minute, I got a virtual machine now on this thing? The answer is yes. The answer is yes. I'm using the new VMware Fusion, the tech preview. Now, this is a tech preview. This is not the, this is what they show, it's still in test, it's not stable. But for the most part, from what I've seen, it works fantastic. It works really, really well. So I'm going to hit the open. I'm going to actually turn on this VM. Again, yeah, this is a virtual machine, ARM-based, ARM64, working on Apple Silicon. I'm going to log in. Yeah, so that guy got it. So that guy, to install cal, so you can do sudo apt install Python 3 and Scapy. That's all you need to do. Sudo apt install Python 3 Scapy. Enter my password. They already installed for me. Fine. I need this up and running. Now, here is a sample program that they have here. The documentation. Okay, so I hear this a lot. From people. The documentation of Scapy is really, again, that's not bad. It gets interesting. It can be a little bit hard to read, which it is. It is a little bit hard to read, and sometimes like Googling and finagling may not help you out but a lot of it is really just plug and play. Try a whole bunch of different things. So yeah, the documentation, let's say for lack of better words, it needs some work. Okay. Really? Okay, wait a minute. Wait. So, okay. Now that being said, okay, let's get to the fun part now. You may be wondering, okay, with Scapy, how do you create a packet? How do you create a packet with a spoofed source IP address? Okay. So let's actually let me show you an example of Scapy on the terminal of how do you actually, and I have a whole bunch of these little videos here. I'll share this one for you because some of the things that may actually come really handy for everyone. I thought I found it. There it is. Bing! This is the video in question. I'm going to show you. So this was from 2 years ago. Still holds true up to this day. So I'm going to play the video. Create a packet with spoof source IP address using Scapy. So this is using Kali. So I'm going to fire up Scapy the first thing. Let's stop. But all you need to, first of all, just fire up Scapy. The next thing is, let's create a packet. Packet equals, now, how do you create a packet? Packet is a variable. But what I'm going to do is I'm going to do packet IP, that means the IP header, source equals whatever I want. The destination also to be whatever, the destination can be anything. Okay. So the first part is, okay, to create a packet, you would do, well, set the IP header. Source equals 1.1.1.1, destination equals 1.92.168.1.215. And then I would want to say slash ICMP. Okay. Then send packet. That's it. Sent one packet. So that means the destination. So I'm definitely not IP address 1.1.1.1. That's actually the DNS. If you want to use Cloudflare's DNS, it's 1.1.1.1. The destination 192.168.1.215 is something on my network. Send it. Boom. That's that. Wait a minute. Does this actually work? On my home network, it does. So I'm going to try this here. So I'm going to actually fire up Wireshark. I actually not tried it, so I can get this horribly wrong. So on Wireshark, I'll just say go to sniffing and spoofing. Go to Wireshark. Oh man, you know what? Sudo Wireshark. There you go. So I can just record anything. So I'm gonna actually record traffic and see what happens. Ah, damn. Okay. Here we go. So I got the virtual machine running. Now, by the way, just want to let you all know, I'm going to fire up a new terminal, new tab, ifconfig. My IP address of this virtual machine locally on my network is 192.168.1.209. Just to keep that in mind. Keep that in mind. 192.168.1.209. Fine. I'm going to capture all the packets. But I'm actually going to type ICMP, so I'm only going to see... What? ICMP. I'm only going to show ICMP traffic. Now I'm actually going to fire up my macOS terminal. I'm going to type Scapy. Now, I'm going to do ping 192.168.1.209. Actually, let me get out of here. Ping 192.168.1.209. And you can see the MAC of the IP address of my Mac OS is 192.168.1.219. The IP address of the Kali virtual machine is running at 192.168.1.209. Again, my Mac OS is 192.168.1.219. I'm going to clear the screen. I'm going to go Scapy now. Okay. So I'm going to do packet equals IP, src equals 1.1.1.1, DST, destination equals 192.168.1.209. Slash, this is going to be an ICMP packet. Also on ping, send packet. See what happens. Sent one packet. Holy shit, it worked. Holy cow, it worked. Oh, damn, it worked. And so it says, you can see that the source IP address is 1.1.1.1, and the destination, you can see, and the destination is this thing right here. That's dope. Oh, that is so cool. Oh, that is cool. Okay, let's do this again. I'm going to spoof the source IP address to be not 192.168.1.219, which is my Mac. Let me just say 8.8.8.8. Send packet. Sent one packet. 8.8.8.8 is the IP address of the, if you want to use Google's DNS server, there it is. So you can see in Wireshark on the Kali virtual machine, it is receiving spoof ping packets from both 192.16 from 1.1.1.1 and 8.8.8.8. Really, really cool. Okay. So this is awesome that it worked better than I thought today. I'm going to exit out. I don't need this today. Actually, I would need the terminal back. All right. So we just did an example of spoofing. We're just spoofing a packet. How to spoof the source IP address for a packet. This all works out. This is great. All right. Then what else can we use? I'm just going to say stop and quit without saving. I don't need this. So what else can you do with Scapy? Um, there are a few examples here. Do they have any examples here? Recipes. They have a whole bunch of recipes. An art monitor, Rogue, DHCP. There's a bunch of things here. Firewalking, TCP, viewing, yada yada yada. One caveat here, one real big caveat is Scapy can be slow. It's not as fast if it's written in C. Just to let you all know. So one of the assignments in my security class, go to comp116.org, is what we call the incident alarm. One of the things that, I know that computer science everywhere, there's a heavy infatuation with programming, but one of the things I want to do with this lab is a hard lab. It's basically really hard to do in the real world because people make, there are a company that does this. But this is a problem solving exercise and also using a real tool. But I asked students in my security class to write what is called an incident alarm. That is, write a program using Python and Scapy to detect things like no scan, fin scan, Christmas tree scan, username and password sent in the clear by way of HTTP, basic authentication, FTP, IMAP, detect a NICTO scan, and of course, someone trying to scan for the remote desktop protocol, which, by the way, is using ransomware all the time. That's why so many computers get hit with ransomware these days. Okay? And I'm actually kind enough to actually give students a starting point, a working a working Scapy program that sniffs traffic on a live network or from a PCAP file. Goal is to actually expand on this to actually, detect these types of scans. Can you do a monkey in the middle with Scapy? You bet. You bet you can. You bet. Oh, yeah, yeah. You bet you can. I've seen examples of this. Here it is. How you build a monkey in the middle? Right there. Boom. You can, it's default user. You can certainly build a monkey in the middle, man in the middle with Scapy and Python tool. Been done. There you go. You certainly can. You certainly can. And there's actually a whole bunch of examples here on GitHub and GitLab as well too, which is cool. You can. No question about it. So, going back a bit. I don't think I need the browser. No, I don't need the browser. But I do have a copy of that base alarm that I just showed from GitHub. By the way, I'm an idiot. Let me just make sure that everyone got a copy of that. Man in the middle. Can you explain a little bit more about the term man in the middle? Yeah, eavesdropping. Think about this way. When two people are on a telephone conversation or two people are on a computer network, how do you actually intercept the traffic? Eavesdropping. Yep. Also known as monkey in the middle, man in the middle. So that's the URL of the starter code that I wrote. Here's the starter code. So, how do I actually get this thing to work? Okay, so I'm on Kali Virtual Machine right now. So how I run this is going to be Python 3 alarm-base.py. Now, notice what happens at, there's a couple of things here. Number one, trying to sniff on ETH0, the network interface, but you see, sorry, can't read network traffic. Are you root? If config. If I do if config, Yep, ETH0 is my, I want to use ETH0 for sniffing. But the most important thing is I want to do sudo Python sudo Python 3 alarm base.py ETH0. And once we get this, we get sniffing on ETH0. Okay, nothing's happening. Well, yeah, nothing is happening because I need to go and visit HTTP, not HTTPS traffic. Ooh, once I open Firefox, actually you can see, hold on. Uno momento, por favor. Let me fire up the terminal. All right. Let me go to reddit.com. Oh, because Reddit is HTTPS. Oh, there's some HTTP traffic I see. Here is a very well-known HTTP website, tufts.io. Boom. Let me clear this again. Let me start the thing, and you can see the thing go absolutely. Hello? Hello? This thing will absolutely go crazy when I hit a hard refresh. Yep, there you go. Tufts.io is HTTP only. You can actually change it to HTTPS, but once you actually go to an HTTP website, the alarm goes absolutely crazy. Now, this is annoying. This can get annoying. This is not the fun stuff. Okay? That's not the fun stuff. But can we actually use the alarm? Can we actually use the alarm? Write an alarm, update this to detect things like fin scan, no scan, Christmas tree scan, username and password sent in plain text, uh, 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 someone's trying to actually use Nicto against you. Also, one thing I should add in the future is to add if someone is actually using Rob Graham's mass scan tool. That's something I gotta add next year. Excuse me. How to actually update the tool to actually detect Rob Graham's mass scan. So here is so everyone always asks, how do I actually grade the alarm? All right, so I have a working alarm here. Python 3 alarm. Here's a good example of an alarm that is actually working. Alarm dash good. I'm not going to show you the source code. We're going to give the answer for the lab. All right, and I'm going to hit enter. It's a working alarm. And again, remember the IP address of the virtual machine is 192.168.1.209. I'm going to fire up a terminal. There we go. Looks good. Let me fire another one up. Okay. Okay, that's good. So I am the attacker. I'm running Mac OS. This is the attacker. That's the victim. The victim is Kali Virtual Machine at 192.168.1.209. I am the attacker. Oop. So I'm going to do so what I'm going to do on my Mac is I'm going to send the alarm, the target, a fin scan by way of nmap. So sudo nmap minus sf 192.168.1.209. What would happen? I'm the attacker. I'm actually going to scan. I'm going to send a fin scan to the target, which is a Kali virtual machine at 192.168.1.209, and the alarm should pick it up. Boom. There you go. Fin scan is detected. All right. How about a no scan? There you go. Pretty cool. How about Christmas tree scan? So this alarm detects a Christmas tree scan is detected from 992.168.1.219. How about Nicto scan? Well, I'm using the source-based Nicto. Nicto is a scanner. It's a tool to scan vulnerabilities on a web server. Perl nicto.pl minus host equals... Oh shoot, I need to turn on a web server. I need to turn on a web server on the Kali the virtual machine. It doesn't have a web server built in, so I can do a hack, which is one nice command line. Minus m http.server port 80. So if you want to have a nice hack job on how to create an HTTP server, like temporarily, without installing like Nginx or Apache, you can do sudo python 3 minus m http.server. Now you can also do this without sudo, and the default port will be 8000. But because in this case I want to use port 80, which is reserved for a lot of web servers, I need to use sudo. That's what happens. So I have now a web server that is running on this Kali virtual machine temporarily. Now I'm just going to do 192.168.1.209 using a Nicto scan. And you'll see Nicto scan. A whole bunch of vulnerabilities here. I don't need this anymore. I don't need that anymore. I don't need this anymore. Clear the screen. Okay, so the alarm looks like it's working. Wait a minute. Alright, I got an alarm here, but can the alarm actually detect username and passwords that were sent in base64 encoding? So I have a folder called pcaps here, a whole collection of pcaps here. Remember set3.pcap from the second lab. So I don't need sudo if I don't need to use, again, I don't need to use sudo for the alarm if I am just reading packets. Minus R. So I'm just going to go home to DEF CON. I'm just going to do my full path. That's read up. Watch what happens. I don't need to use sudo if I'm reading in a PCAP. Boom. Remember that? So this person actually wrote the alarm well. Here it is. The alarm actually detects the 3 username and password that were sent in plain text. Yep. Base64 encoded credentials. The person's alarm actually decoded them. So yeah, that's stuff that you can do with Scapy. You can do Scapy for reading packets and writing packets. But don't take my word for it, because I think the better thing is, now, what I want to do is I want to, actually, time for me to, probably my favorite one part of today is to introduce you to John Hammond, cybersecurity extraordinaire, and he's going to give a talk. I don't need this anymore. He's going to give a talk on Scapy. Yeah, so I'm going to have John take it away. This is an absolute oldie but goodie talk. Let me turn it over.
Alrighty, hello everyone. Welcome. Thank you for tuning in. I appreciate you being here. This is a talk and presentation titled Take Down the Internet with Scapy. I'm presenting this as part of DEF CON 28 or DEF CON Safe Mode, and I'm here at the Packet Hacking Village. So let's dive into the presentation, but before we do, I've got to say this. I've said it before, I'm about to say it now, and I'm certainly going to say it again many, many times throughout the presentation. Thank you. Thank you for being here. Honestly, seriously. So the classic disclaimer, right? The start of every talk, that's just how it's got to start. These are my words, not my employers. I don't represent them. I'm not speaking for them, etc. This is stuff that I wanted to bring to you, me personally. Other disclaimer, don't or do try this at home, right? Anything that we talk about, anything that I showcase here, obviously it's a talk titled Take Down the Internet. Don't actually do that, or maybe do it at maybe your own small scale lab environment, etc. You can tinker with it and explore with it, but don't actually take down the internet, right? Cool. Next, your mileage may vary. I bring this up with everything that I kind of try and showcase. Look, I'm talking about it and I'm showing it to you. Maybe you'll have different results. Maybe something will work differently or strangely in the way that you do it if you do this sort of thing. I can't promise, and I don't mean to make this any written in stone gospel or anything. The stuff that comes out of this talk, it might be different for you, and your mileage may vary. Okay, last bit. We're the good guys here, right? We talk about security. We talk about cybersecurity. We break things for the sake of making them better. We hack for good. And I want you to do the same. The stuff that we're going to talk about and showcase in this presentation, maybe it's a little bit on the different side of the fence. I want to reiterate to you and kind of enforce it. Hey, hack for good. Okay, obligatory introduction, right? Who is this guy talking at you? Hello, my name is John Hammond. I'll try and run through this quickly because I know no one cares, not even me. I used to just do some stuff with the Department of Defense Cybercrime Center and their Cyber Training Academy, and I also work with the Defense Threat Reduction Agency as a kind of a red team cyber operator. Right now, I'm working as a senior security researcher over at Huntress Labs. Again, not speaking for them. These are my words, not theirs. And in my free time, I like to play a little bit of Capture the Flag. I like to develop and create and host Capture the Flag events or competitions or exercises and training sets to try and make people better, to try and improve everyone's cybersecurity skill. On that same coin, I do produce some cheesy YouTube videos. I publish and showcase some Capture the Flag write-ups or programming tutorials, video guides, stuff like that. But that's all nerdy stuff that you don't really have to care about. Let's talk about what we're going to talk about. Kind of meta, right? So here's the agenda, the roadmap, the outline for our discussion. First, we'll lay the groundwork. We'll put down a little bit of a background, really set the scene for what we're going to be discussing. I'm going to be talking a little bit about Python, right? Python's kind of my weapon of choice, but we needed to make a distinction between Python 2 versus Python 3 and what we'll kind of be using as our vessel throughout this talk. Then I'm going to introduce Scapy, one really, really cool Python module or library that you can pull into your Python source code, use with your projects, your other scripts, whatever you're working on to do really, really cool low-level stuff with network packets, with the stuff that you would find in PCAPs, if you would take a look at it in Wireshark or TCP dump, etc. We're going to do that with Scapy inside of Python. So we'll talk about how to install it, some documentation, syntax, and use cases, etc. Then we'll get into the real meat of the conversation. We'll talk about different attacks that we could perform, and we'll kind of zoom in or zoom out as appropriate on some of these different things. The ping of death, the SYN flood, DNS attacks, BGP, etc. I do want to showcase a couple of IRL or in real life cases, right? Stuff that we've really seen out in the real world that is real. All about the stuff that we're kind of laying the foundation with here, Python, Scapy, and these network attacks when we're trying to take down the internet. We'll also discuss some of the defense and mitigation, some things that we could do, some things that we might consider when we take note of all these network attacks we're going to be looking at. Finally, I'll showcase some of the resources and references that I use to put together this conversation, this talk for you, and we'll have the boilerplate template slides, how you can contact me, and of course, I will thank you again and again. I'm really, really appreciative that you're here. All right, let's get into it. To get things rolling, let's lay the foundation. We're going to be talking about packets, right? We're here in the packet hacking village. We're talking about network-oriented stuff. So naturally, we're going to be talking about packets using Scapy, using Python, and we'll dive into that more. But I want to say the title of this talk, right? The whole theme, take down the internet, that's going to be doing a lot of kind of jerk stuff. It's about obnoxious, annoying, adversarial, and disruptive attacks. So nothing like elite, super cool, 0 days, crazy like Ninja Warrior cyber hacker stuff, but really just being mean and breaking stuff. We're trying to recklessly break stuff. I want to showcase some of this to you because I want to show you just how easy it is and how Python, just the same scripting language that's about on every Unix system, can do this stuff. And how you could do it if you really wanted to, but you shouldn't. You don't have to, right? Take down the internet. Obnoxious, annoying, adversarial, and disruptive attacks. That's the background. All right, now let's talk a little bit about Python. I'm going to be using Python as the vessel for this talk, right? We want to make this a little bit of a technical talk and showcase some code, showcase some real stuff, rather than just pointing at numbers on a graph. So I want to lay the foundation again with Python. Python is a wonderful hacker's language. Yes, it's a scripting language. It's not compiled. It's read through an interpreter, but it is easy to read and easy to write. That means that it's super duper friendly. It's really easy to knock out quick testing scripts or to rapidly prototype some ideas. It's just handy and useful and has a lot of support between all the different libraries and modules and packages that you could pull into your code and do some really, really neat stuff. So there's some conversations, right? Because now we are in a new era. We are in 2020 and Python 2, the older version of Python, is dead. It's not on the table anymore. Python 2 reached end of life at the start of this year, and now Python 3 is the officially supported version. Please don't hate me for screaming about that. I just want to make sure, hey, everyone knows we're using Python 3 and you should be too. And of course, Python is part of Linux. It is typically shipped and natively kind of built into a lot of common Linux distributions. And honestly, you should be using Linux. I don't know why you wouldn't be. And because it is part of Linux, it's really, really easy to access it just from the command line. You can simply type in Python, and then you're inside of an interactive shell or interpreter to work with the Python language. I'm kind of being explicit here. I'm using Python 3 with that suffix 3 at the end. You probably will just be able to invoke it as regular Python, and maybe that would spin up Python 3 for you. But if it does, fire up Python 2. Hey, you should know better. Go fix that up and hop over to Python 3 now as the officially supported version. Python, while we could be working inside of the language within the interpreter or within that shell, oftentimes you'll likely want to create a script or file with a .py extension, maybe a shebang line, and you can invoke it and run it with Python just as an automated tool, not manually working through the interpreter or the interactive shell there. In a lot of our conversations, what we'll be discussing, I am assuming you're going to end up using this inside of a script with a .py extension, and you don't need that interactive interpreter. Okay, let's move on because you probably all already know about Python, and this is boring. So let's talk about Scapy. Scapy is incredible, fantastic, phenomenal. It is a module, it's a library, it's something you can just install, pull in to use with your Python code, and it gives you the ability to craft network packets. You can customize them, you can forge them, you can create them, you can whatever you want, your wildest dreams, whatever sort of network layers or protocols or things that you want to use, you can get that fine-tuned, like zoomed in microscopic customization of what that packet looks like. And that's super duper cool. It's easy to install. I'm showcasing some commands here. I'm assuming, okay, a Debian-based distribution, maybe Ubuntu, you'll do a little sudo apt update and you'll install pip if you're working with that little handy Python package manager. And let's use pip install Scapy. Now, you could run Scapy in one of two ways. Very, very similar to what we talked about in Python, right? Scapy could be interactive, and you could work inside of an interpreter with a manual, like typing in commands and getting that return back to you, like interactive shell. Or you could work with it inside of a script and have Python just import Scapy as a whole module. And you can access all of the code, the functions, the variables, all of that functionality that Scapy offers inside of your Python scripts, inside of Python. Now, this is crazy cool because we can work with TCP packets, UDP packets, any other network stuff, maybe CAN bus protocols or Bluetooth. There's so much more, and we could dive into some of the documentation for Scapy. I always want to point people to the real documentation because that's where the real stuff is, right? I'm not going to be the expert. Sorry. I don't think you would call yourself the expert. And I'm not saying that to be mean. I'm just trying to say the source code is the truth, right? Documentation is the real accurate stuff. That's what's really there, really built in. And the official source, it's what's good to go to when you need help or you're trying to learn something new. Obviously, there's a man page for the command if you wanted to fire that up. Obviously, they've got an online web presence. You can check them out at scapy.net. And they have official documentation over at readthedocs.io. And of course, a GitHub page. So you can go take a look at the source code. It's open source. It's awesome. It's all Python, good stuff. The website is actually fantastic. They have a page over there called Awesome Scapy, and that will showcase other tools, exploits, and some sample code to use, and it's really, really cool. They have some good stuff on Wi-Fi, like mapping and tracking Wi-Fi networks through 802.11, making a roaming access point, performing some man-in-the-middle attacks, some Tor, onion router protocol stuff, tons and tons of great stuff, even CVEs and exploits for common attacks, or stuff from Crack, the attack against WPA2. Super duper cool. Really recommend you go check that out. Okay, now let's talk about the basic syntax of Scapy, because if we want to use it, we have to know how to. I say that Scapy is Pythonic in that the syntax that it uses when you're working with the module, you're working with Python objects, right? The same way most everything in Python really is that you're interacting and working with an object that has methods and properties and all these attributes and things you could work with that are really under the hood, right? Functions and variables, just with a kind of a different decorated name. But being object-oriented means we can do some kind of nifty things with it. Maybe not all the time. I'm not trying to say OOP is the way, but it's nice to have that kind of built into the language when necessary. So you can see I'm working in like a little bit of a script here, right? I've got a shebang line set up. I'm going to work with Python 3 as my interpreter, and I'm going to use that from scapy.all import everything, or the asterisk, the star, the wildcard, to pull in everything that Scapy module has into my current namespace, so I can interact with it and I can work with it through Python. So here I'm going to create an object or a little variable, ping equals, and the IP, this big class name, right? You can see the capital letters there. That's going to return a Scapy object, and it's going to be a packet, and I can define how that packet looks. Maybe I don't want to use an IP, or maybe it's that specific header for that protocol. I could zoom in on other things between TCP, UDP, HTTP, or anything else. And Scapy already has support for all those crazy cool protocols and layers, and you could just pull them in and work with them. Or if you really wanted to, you could go do a little deep dive, get in the internals, and build your own. So note inside here, I'm creating this IP object, and I'm passing in a keyword argument. I'm saying DST, or the destination IP address. I've simply set that to a string, 192.168.1.1, and I've had a little division symbol, or that forward slash, which looks weird, right? Because we're not dividing these objects, but I'm using that syntax, and that is the syntax that Scapy uses to actually add layers in or kind of build them into that packet that we're crafting. So now I'm going to say this is simply going to be an ICMP packet or ping packet, right? I've assigned that to that ping variable or the object, and I'm just going to print that out on the screen. If I were to run that script, check out down below. Now I have that kind of B prefix to note that this is a binary string, or I'm just including real raw bytes here. And that \x, the \x everything, all those are the bytes to this packet that I've just formulated and created in a super duper simple way, right? It literally took one line of Python code, and now I have a ping packet. And I could do this. I could send this packet. I could receive the information that comes back, maybe a little echo, a request, reply ping. That's very, very cool. All in a script, all automated and extensible, whatever way that I want, and super duper short, right? One line of that Python code, easy to read, easy to write. Obviously, Scapy is abundant, and there are more examples of this sort of thing on their website and their documentation. And that's really, really why I'm pointing you all towards it, because that's where the good stuff is. We're going to cover some cool stuff in the talk, but if you want to go deeper, learn more, do some more research, I'd recommend, hey, go check out that documentation. Okay, last slide on Scapy, I promise, then I'll shut up about it and we can move on. I'm not trying to sound like an evangelist here, but I am trying to show to you all of the cool things that Scapy can do. Obviously, in this last slide, we just looked at a super duper small, minuscule example of one thing that Scapy could do. What we could do with that packet, or with many other packets, is put that together into a PCAP file, write it out to a packet capture archive. Or we could read in a packet capture archive or a PCAP file, read through it, loop through it, do interesting things with it. Or we could sniff and listen and actually capture live packets and dissect them or forge new ones, etc. With filters, import and exports, create graphs, reports, tables, etc., etc. And obviously, all of those specific different protocols that we would want to work with, we can. And then maybe we could turn it into more of the offensive side. We could probe or scan or attack networks, fuzz specific aspects of a protocol, or send malformed packets. And we could do crazy tricks like, okay, ARP poisoning, or do some specific kinds of scans, etc., etc. The benefit behind all of this, and this is what makes it so awesome, is that it can all be automated and you can write it and you have that fine-tuned control all within Python. You have the entire arsenal of the Python language and libraries, modules, other tools that you can use and pull into it. So that's super duper cool. Now let's get into the good stuff. Let's get into the really cool attacks that could potentially take down the internet, right? So we'll start small, we'll start with some simple things, and then we'll slowly kind of zoom in onto more complex stuff. But just to kind of whet your appetite, let's start with the ping of death. Interesting name, right? So the ping of death attack is a denial of service attack where the attacker will stop a machine by sending a large ping packet. So large, in fact, that the machine can't handle it. It'll choke. There's so much data in that packet that the machine doesn't know what to do with it, and it'll freeze up or just fall over or crash. We talked about ping packets in the previous example, or that script and source code that I showed you earlier, when we were looking at that ICMP protocol, or the Internet Control Message Protocol. So typically, ping packets are very small, but IPv4 ping packets can be much larger, up to the maximum allowable packet size of 65,535 bytes. Some systems might not be designed to actually handle packets larger than this maximum, and they might be vulnerable to packets at that size, and they're sensitive to it, they'll choke, and they'll fall over. When this large evil packet is sent from the attacker to the victim, the packet becomes fragmented into different segments, each of which will be smaller than the maximum size limit. When the target and victim actually attempts to put these pieces all back together, eventually that total size will exceed that maximum size limit, and maybe a buffer overflow occurs or something goes wrong and that machine can't handle it. It'll freeze, it'll choke, it'll crash. So we're using this example where the ICMP echo or that ping packet could be used for this attack, but really anything that sends an IP datagram that can hold more data or can have this attached information that extends beyond that maximum size could be used for this attack. That could be TCP or UDP or any IPX stuff. Admittedly, the ping of death attack is kind of old and a little outdated, but I think it works as a really cool and simple, quick jumping off point or starting point for us to take a look at some of these evil, nefarious things that we could do with Python and Scapy. So with that said, let's take a look at the source code here. You can see I'm using the send function, which is part of Scapy. We say we've imported everything into our namespace. You could also send just one packet and receive the information back, or send packets inside of a loop. But for just one quick shot, firing the gun, we can use this send function here. We'll create a fragment, as kind of we discussed earlier. Okay, sending fragments that might be rebuilt and reassembled by the victim machine that could potentially cause it to crash and choke. And inside of that, we'll build this ICMP packet just as we've done before in that previous example. However, you can see there at the end, we use another divider or to add in another layer or some more information into this packet. And I just use a simple dummy string. I just use the letter X and I multiply it by this large number. So I have this data payload, this information that I've strapped to this ping packet so that I can send a ping of death that's just a little too big. And maybe that machine is biting off more than it can chew. It'll choke and it'll fall right over. I did mention, though, that this ping of death attack is less common today, right? More so now, you'll see other kinds of attacks that are still this denial of service attack, right? We're being a jerk. We're overwhelming, flooding, and just bogging down the resources on that victim or target. So one of the more common ones you'll see now is perhaps an ICMP or a ping flood. And we can certainly send other kinds of floods. One of the most common ones you might see is a SYN flood. SYN flood is another denial of service or DDoS attack, which will make that server, your victim, unavailable to respond. It'll be just too busy. It'll be bogged down. It'll be hosed because something will be consuming all of the available server resources. We're going to cause that by sending packets with that SYN flag set. So you know TCP packets, right? TCP being the transmission control protocol, which ensures there is a connection in place by using the three-way handshake, right? The client on one side of the conversation will send to the server a packet with the SYN flag set to synchronize or start the conversation and begin requesting communication. The server over on the other end of the conversation will say and respond back with a SYN ACK packet or a packet sent with those flags set. Finally, the client, knowing that the server has responded, that someone actually answered the phone, it will respond once more with an ACK flag set on a packet, or the acknowledgement, okay, someone is listening and we can talk, we can have this conversation. Interesting thing though, on step 2 of that process, or in the middle of the three-way handshake communication, the server, while it sends that SYN ACK packet, it will wait to receive that ACK packet from the client so that it can begin having this conversation. So, the attack is simple. We just send a ton of SYN packets where we're just starting all these conversations. We're dialing the phone, but once someone answers, we don't care. We don't respond to them with an ACK packet. So they're overwhelmed, right? The phone keeps ringing. They're going to pick it up and they're going to want to talk to someone, but no one will be there. They're just not having this conversation, but they're still holding the phone and more are ringing. That will hog all the resources. That will cause that target victim to not be able to respond to other legitimate traffic because, okay, hey, they're busy, tied up with other stuff. All those resources are being utilized right now. Because this attack brings that server to the halfway point in the three-way handshake, right? They've started the communication but have not responded to the server's acknowledgement. That means that it's halfway communicated. That's why it's called that half-open attack. Kind of interesting. So let's take a look at the source code, right? Scapy, again, makes this super duper easy. We're performing this attack in, realistically, 2 lines of code that could even be shortened to 1 because, hey, maybe we could abstract out that object that's not necessary for that SYN flood. We could just pass that to the function. So I'm creating the SYN flood object or variable, right? I send in a keyword argument for the destination. Again, just an IP address we'll use. We'll set an ID number for that packet and we'll specify the time to live. These values aren't extremely important for kind of just our discussion, but obviously that next layer certainly is. We create a TCP portion of this packet, and that sport, or S port is how you should read that, for our source port, that's just going to be a random ephemeral port that Scapy will help us generate with that rand short function there. That'll return something that make it look like, okay, we're coming from a different port every time. The D port, or the destination port, will be passed in as a list or a little Python array. We'll just send this over to port 80 HTTP. You could specify this to whatever you wanted to, maybe SSH or anything specifically. Specify a sequence number, specify an acknowledgement number. Again, for this example, those don't really matter all that much, but maybe they could in other scenarios. The window size, and the most important thing here, the flags that are set on this TCP packet. Obviously, I'm just passing in a string here with that capital S, and certainly enough, that stands for SYN, right? The SYN flag has been set on this packet. So we have created one packet that is just a SYN packet, the very, very first step in that TCP three-way handshake. The next line below, we're going to end up using that SR loop function that Scapy makes available to us. And that is going to send and receive packets in a loop. So we will repeatedly, over and over and over again, send this packet. The keyword arguments there, that inter or the interval, we'll send those at 0.3 of a second. We'll retry every 2 seconds if that kind of gets dropped. And we'll have a timeout of 4 seconds. Again, those are a little extraneous, but the point that we're getting across right now is that we are looping a SYN packet being sent over and over and over again. We are flooding that target victim server with this SYN flood attack. In the case of the line of code there, we have an answered and unanswered information that's being stored as a return value of that SR loop. That'll just return a tuple, okay, or a list of what packets actually had a response and what didn't. The point that I'm trying to get across is that just these 2 lines of code are putting together this attack. And it's super duper simple. All you've done is outlined the structure. You've orchestrated this packet, and now you can put it to work. You can weaponize it as a SYN flood. You might notice, though, in this example, with this setup right here, we're sending this SYN flood attack just with our attacker machine. One machine. So potentially, that endpoint or that target, the victim server, once it realizes, hey, I'm under attack, right? I'm in danger. If they kind of had the opportunity to look through some logs or could figure something out and determine, oh, I know the source of this attack, I can just block it off. Well, you're totally right. That's absolutely doable. For that reason, this kind of thing isn't often done just with one host, just with one attacking machine. So you bring into the conversation, okay, we're performing a denial of service attack, a DOS attack or a DOS attack. But if we had more machines in this pool, if we were attacking with multiple hosts, we could be performing a distributed denial of service attack, or that DDoS, DDoS. That might make it a little bit harder to do, harder to track down, harder to trace. However, we could do even more. We could go one step beyond that when we say our source IP address, we don't want that to look like it's coming from us. We want to hide it. We want to mask it and obfuscate that just a little bit more. But you can tell with Scapy, we are crafting our packets at the granular level. What's to stop us from specifying just that information, just the bytes, the real information that we need within that header of the packet? We could say that our source IP address comes from a different IP address, comes from a different host. We can spoof our IP address simply by passing in the keyword argument. Just as you see the example there, we specify that DST keyword argument as an IP address string. We could just as easily specify SRC, or the source IP address, and make it look like we are coming from a different location. We can spoof our IP address super easily with Scapy. And we can use that as a segue into the next attack, DNS amplification attacks. A DNS amplification attack is a really interesting technique that abuses the regular functionality of DNS, or the domain name system, to again overwhelm, spam, and flood a target or victim machine. The way that this works is that the attacker actually sends a legitimate regular request to a DNS name server asking for as much information as they can. So their request is a regular kind of small, tiny packet just asking for information, and the domain name server will respond with as much information as possible, and that way you get a much larger packet in response. The trick here is that with this DNS amplification attack, the attacker sets their IP address, the source, back to the actual victim or the target server that they're aiming to overwhelm and choke. You can see this here in the source code, right? We're defining, again, another object or variable to keep track of our packet. We're defining an IP header, but interestingly enough, we supply that src keyword value or the source IP address of the packet that we're going to be formulating. Note, this will act as our victim. This is the target machine that will have the domain name server send back that large request. You can see again our division symbol or the / to add new layers, and we're adding a UDP packet portion, right? We'll set the D port or the destination port to 53, the default port for the domain name system or DNS servers. And what we're going to query from this DNS is anything we'd particularly like. Here, I'll just ask for anything regarding google.com or that domain. You could, of course, ask for any type or any resource record you'd like, an A record, a text record, a CNAME record. Generally, with this attack, you could expect to see the attacker request for any, as in return all of the resource records you could give me. We'll have that packet formulated, stored, and encapsulated in that DNS amp object and variable, and again, we will just send that packet along. The DNS server will respond accordingly. It will give all the information it can, but send it to that source IP address, not our actual attacker. That will flood and overwhelm, choke that target victim server. Obviously, you'd want to have more than one attack or one attacking machine doing this. You could perform this distributed denial of service, right? That DDoS, or send this request multiple times. But I think this attack is really cool and really interesting, right? If you put it in kind of layman's term or normal human explanation, say you are at the drive-thru ordering some fast food to go or whatever the case may be. Let's say you ask the person or the teller that's chatting with you and taking your order, I want one burger or I want one drink or whatever. Typically, that job of the teller will read back your order, right? So envision this scenario. You as the driver, right? You as the attacker, you say, I want everything on the menu. And then before they can read your order back to you, you drive away and let that next person go ahead and actually hear all that information. So while you just asked for a small tiny thing and a simple, hey, give me everything you've got, the next person or your target or your victim is going to be read and enumerated and receive all of the information. So maybe, I don't know, what a 1 scale for your packet could respond to a 10 in the response and what that teller will read out to that other person or that individual. Kind of cool. And obviously, another added benefit to this is that the attacker is performing this attack indirectly. They make this request out to an open and accessible DNS resolver, and it will respond and just send that information out to the actual target or victim themselves. The attacker doesn't really leave any fingerprints or a trace on the target. It's not reaching it directly. It is an indirect attack. You can see that here again with that syntax, but as always, Scapy is making this really, really simple and honestly really easy. Okay, now let's talk about our finale attack. I want to discuss...
All right, I think I'm going to stop there. So I'm going to stop there because we're running out of time. So as always, thank you so much to John. One of the things I will do is, if you're interested, I got the full video of John's talk, so if you flip back and forth to it. Been fun. So, what about next week? October's tomorrow. October is tomorrow. And October is a very special month for not only this course, but for cybersecurity. October is National Cybersecurity Awareness Month. October is also Breast Cancer Awareness Month as well, too. So next week, we're going to crack passwords. Yeah. So it's customary for this course to have a password cracking competition. And it's a 1 month long competition. Anyone that cracks all the password get an automatic A plus. But next Thursday is going to be on password cracking with John the Ripper. I'll see you next Thursday.